You turn the key, the dash lights up, the starter cranks, and the engine just won't catch. Or maybe it starts for a second and dies like someone flipped a switch. The first thought is almost always the same: the fuel pump is dead. And if you've been searching fuel pump not working on Toyota Corolla Cross, you're probably already halfway to ordering a pump module you might not need. Here's the uncomfortable truth: a Corolla Cross can act exactly like it has a failed fuel pump even when the pump itself is perfectly fine. Because the pump is not a simple, key on, pump runs, device anymore. It's part of a chain of permissions. Battery voltage has to be healthy, the car has to be allowed to start, the control side has to command the pump, and the wiring has to deliver power and ground under load. If any link in that chain breaks, you get the same symptom: no fuel delivery, no start, or a sudden stall. So the goal isn't to guess. The goal is to separate three different problems that feel identical from the driver's seat: no fuel because the pump can't run, no fuel because the pump isn't being powered, or no fuel because the car is intentionally cutting it. Start with the fastest reality check: is this definitely a fuel problem? A modern engine needs air, fuel, spark, and permission. Permission is the immobilizer and the ECU's logic. If the security system isn't happy, the car can crank all day and never truly start. If the battery is weak, it can crank but the voltage can sag so low that modules drop out and the fuel system never behaves normally. And if the engine isn't actually cranking at a normal speed, you can chase the fuel pump forever and still be wrong. Listen to the way it cranks. A healthy crank has a steady rhythm and speed. A weak battery crank sounds lazy, like it's dragging. That matters because fuel pumps and control modules hate low voltage. If you have a multimeter, you're looking for a battery that's solid at rest and doesn't collapse during cranking. You don't need to memorize a magic number to understand the principle: if the voltage drops hard when the starter engages, the car can behave like multiple systems failed at once. If you don't have a meter, try a jump start from a known good source and see if the behavior changes. If it suddenly starts or tries harder, you just learned something important: you may not have a pump problem at all. Next, check the obvious that people skip because it feels too simple: fuel level and fuel quality. If the gauge is low, don't trust it blindly, add a small amount of fresh fuel. If the no start happened right after refueling, that's a clue. A bad batch of fuel, water contamination, or even a loose or damaged cap causing evaporated weirdness can create symptoms that send people straight to a fuel pump. It's not the most common, but it's common enough to be worth a minute before you start pulling connectors. Now the famous listen for the prime test. People say you should hear the pump buzz for a couple seconds when you turn the key on. Sometimes you can. Sometimes you can't. Some systems are quiet, some only run the pump during cranking, and some vary the pump speed. So silence is not a conviction. It's just a clue. If you do hear a brief hum from the rear area, that's a strong sign the pump motor can run and the circuit can at least wake up. If you hear nothing, don't panic and don't order parts yet. Look at the dash while you're doing this. Any security indicator behaving oddly? Any warning messages that suggest the car isn't recognizing the key? If the immobilizer is active, the engine may crank but fuel injection and pump command can be inhibited. That's one of the most expensive misdiagnoses because you can replace a pump and still have a no start. If you have access to a scan tool, even a basic one, use it early. Not because you need to become a technician, but because codes and live data can prevent you from wasting hours. A crankshaft position sensor issue, for example, can cause a crank no start and the ECU may not command fuel the way you expect because it doesn't see engine speed. That can mimic a fuel pump failure. Likewise, certain power supply codes, immobilizer-related codes, or communication codes can point you away from the tank and toward the front of the car. Now, before you touch anything electrical, a safety reality check. Fuel vapor is not forgiving. Work in ventilation, keep sparks and open flame away, and don't test things by randomly jumping power unless you know exactly what you're doing. If you smell strong fuel, stop. A fuel leak changes the entire risk picture. Also, repeated long cranking isn't harmless. You can overheat the starter, drain the battery into the danger zone, and if the engine is trying to fire intermittently you can stress the catalytic converter. If you've tried several long cranks already, pause and reset your approach. Here's where most people go wrong: they replace the pump because it's the most dramatic part. But the pump is downstream. Upstream are fuses, relays, control modules, grounds, connectors, and the ECU's decision to run it. The fastest way to avoid a bad purchase is to check the easy electrical items first. Fuses are not just, look at it and it's fine. A fuse can look intact and still fail under load or have poor contact. But you can still do a quick check, locate the relevant fuel system fuses and inspect them, and if you have a meter or a test light, verify power on both sides with the key in the appropriate position. If you're not comfortable identifying the correct fuse, use the owner's manual or the fuse box diagram. Don't guess and don't upsize a fuse. If a fuse is blown, that's not the end of the story, it's the beginning. Fuses blow for a reason: a shorted wire, a failing pump drawing too much current, water intrusion in a connector. Replacing the fuse and sending it is how you turn a small problem into a bigger one. Relays are the next trap. A relay can click and still not pass current properly. Or it can fail when hot and work when cold, creating an intermittent stall that fixes itself after you wait. If your Corolla Cross has a relay you can swap with an identical one in the box for a quick test, that's a clean way to learn something without buying parts. But don't force it if you're not sure they match. The point is to test the idea: is the pump not running, or is the pump not being fed? Also pay attention to patterns. If the car dies after hitting a bump, or it won't start only when it's hot, or it stalls and then restarts after a few minutes, that screams connection or control more than pump motor instantly died. Pump motors can fail intermittently, yes, but wiring and relays do that all the time. Now we move from guessing to confirming. This is the moment where you stop asking, does it sound like a pump, and start asking, is the pump receiving power and ground when it should? This is also where the search, fuel pump not working on Toyota Corolla Cross, should lead you, because it's the difference between a diagnosis and a parts cannon. To do this properly, you need access to the pump connector or an accessible point in the harness. Depending on the vehicle and configuration, access can vary. Sometimes there's an access panel under the rear seat area, sometimes not. If you can't access it safely without tearing the car apart, that's a valid stopping point. But if you can reach a connector without opening the fuel system, you can do a lot with a multimeter. You're looking for two things during crank or during the brief prime event: battery positive supply to the pump and a solid ground return. The key detail is during crank. Many people probe the connector with the key on, see nothing, and conclude the pump is dead. But if the ECU only commands the pump while cranking, you'll only see voltage then. So you either need a helper to crank while you measure, or you need a meter that can capture min/max, or you need patience and repeatability. If you see proper voltage at the pump connector during crank and the ground is solid, yet the pump is silent and the engine won't start, that's when the pump module becomes a real suspect. Not a guess. A suspect. Because now you've proven the car is trying to run it. If you do not see voltage at the pump connector during crank, that does not mean the pump is good. It means you have an upstream problem: a fuse, relay, wiring break, corroded connector, poor ground, or the ECU is not commanding the pump. That's a completely different repair path, and it's why replacing the pump often does nothing. Grounds deserve special respect because they can look fine and fail under load. A corroded ground can pass enough current for a test light to glow but not enough for a pump motor to spin at pressure. This is where voltage drop thinking matters. Instead of only asking, do I have 12 volts, you ask, how much voltage is being lost in the wiring while the pump is supposed to run? If you're not used to voltage drop testing, keep it simple: measure voltage at the pump while cranking. If it's significantly lower than battery voltage during the same moment, you likely have resistance in the circuit, corrosion, a weak relay contact, a damaged wire. That can make a healthy pump act dead. Intermittent problems are the hardest. If the car sometimes starts and sometimes doesn't, try to catch it in the act. When it fails, immediately check whether the pump is being commanded. If you wait until it cools down and starts again, you lose the evidence. Heat-related relay failure, connector expansion, and marginal grounds love to hide. What about fuel pressure testing? If you have the tools and a safe way to connect, fuel pressure is the physical proof that fuel delivery is happening. But not every setup makes this easy for a DIYer, and you should not improvise with fuel lines. The concept is still useful. If the pump runs but pressure is low, the issue could be a weak pump, a clogged filter integrated into the module, a restriction, or a pressure control problem. If the pump doesn't run and pressure is zero, you're back to electrical command and power delivery. There's another subtle failure mode: the pump runs, but the engine still won't start because injection isn't happening, or because the ECU is cutting fuel due to missing crank signal, or because the immobilizer is blocking. That's why scan data matters. If the ECU doesn't see RPM while cranking, it may not deliver fuel properly. If it sees RPM but still doesn't fire, you look elsewhere. The pump is only one actor. Let's talk about the starts then dies scenario, because it's the one that convinces people the pump is failing. The engine catches, runs for a second, then shuts off cleanly. That can be fuel pressure bleeding off, yes. But it can also be immobilizer behavior, the car allows an initial start and then cuts. It can be a throttle body or air issue. It can be a sensor that drops out as soon as vibration begins. The way it dies matters. A fuel starvation stall often feels like it's running out of breath, stumbling. A clean cut can be electrical or command related. And then there's the battery again. Low voltage can create a perfect storm, the starter draws the battery down, the ECU resets or behaves erratically, the fuel pump command becomes inconsistent, and you end up convinced the pump is not working. Fix the battery or charging issue and the fuel pump problem disappears. That's why the pump is often the last thing you should replace. Not because pumps never fail, but because they're downstream and expensive, and the car has many reasons to keep them off. So what do you do with your results? If you have strong battery voltage, the engine cranks normally, you've checked the relevant fuses and relay behavior, and you measure proper power and ground at the pump during crank, yet the pump does not run and you have no fuel pressure, then the pump module is a logical next step. At that point, replacing it is not gambling. It's responding to evidence. If you have no power at the pump during crank, stop blaming the pump. Focus on the control side. That can mean a relay that isn't being energized, a fuse that isn't being fed, a wiring issue, or the ECU not commanding the pump because it's missing a prerequisite like crank signal or key authorization. This is where a scan tool can save you again. If you see immobilizer-related faults or no RPM signal, you don't crawl into the rear of the car, you fix the reason the ECU is refusing to run fuel. If you have power but the voltage is low at the pump compared to the battery during crank, you chase resistance, relay contacts, connectors, grounds. Cleaning and repairing a connection can bring a dead pump back to life because it was never dead. It was starving electrically. If the problem is intermittent and you can't reproduce it safely, that's a valid point to stop and get professional help. Intermittent fuel delivery issues can leave you stranded in unsafe places. Also, if you suspect a wiring short because fuses blow, don't keep replacing fuses. That's how you melt harnesses. One more common pitfall, people test with a simple test light, see it light up, and assume the circuit is good. A pump is a motor. It needs real current. A corroded connection can light a test light and still fail under motor load. That's why measuring voltage while the circuit is commanded is so valuable. It's not about fancy tools. It's about testing under the same conditions that fail. And if you do end up replacing a pump module, the job isn't done when the engine starts. You verify the fix by checking for consistent starts hot and cold, listening for abnormal pump noise, and making sure you didn't create a new problem like a loose connector or a pinched line. Many repeat failures are installation related, a connector not fully seated, a seal not seated, a harness routed where it rubs. If you came here because fuel pump not working on Toyota Corolla Cross describes your situation, the smartest move is to treat the pump as the final suspect, not the first. Prove whether the pump is being powered and grounded when it should be. Prove whether the car is allowing fuel delivery. Then choose the repair that matches what you measured, not what you feared. Because the paradox is this, the symptom screams fuel pump, but the Corolla Cross is perfectly capable of making a healthy pump look guilty. When you follow the chain, battery, permission, command, power, ground, then pressure, you stop guessing. And you stop buying parts to solve a problem that was never in the tank.